Hello guys, I'm Wenjia. Welcome to my channel. In this video, we are talking about cryptography. To be more specific, we're going to find out what is SHA256 and why it's used in blockchain. We're going to understand what role SHA256 is playing in blockchain. Before digging into SHA256 algorithm, let's outstretch our arms and check our fingers. What do you see? Fingerprints. That's right. Everyone has their own fingerprints. Different people have totally different fingerprints. But there is a possibility that somebody could have the same fingerprint as you. However, it's very, very unlikely. The chance of identical fingerprints is 1 in 64 trillion. So in a way, we can say that a fingerprint is an identifier of a person. And that's a very powerful concept. That's why police can use fingerprints to solve crimes. Now, what if we could take the same principle and apply it to digital documents? What if we could come up with a sort of fingerprint that would identify these documents for us? And boom, we did. Such a fingerprint for digital files exists. It's called SHA256 hash. And it looks like this. That's right, this is where SHA256 hash came from. It was developed by the US government's National Security Agency. The full name is Secure Hash Algorithm 256, and 256 is the number of the bits it takes up in memory. We can put a block into SHA256, a special hexadecimal number will be produced. This number is called a digest or a hash value. The hash it produced is always 64 characters long, and it consists of, as you can see, not just digits, but actually letters as well. That's because it's a hexadecimal hash. It has numbers from 0 to 9 and letters A, B, C, D, E, F. So there is a total of 16 of them. NSA developed quite a few secure hash algorithms. Why SHA256 is used for blockchain? Let's figure it out step by step. So we have talked about putting blocks into SHA256 and getting their hashes. Actually, any digital object can be put into a hash function and get an almost unique hash. Not only a data structure like a block, but a document like a PDF, a book, even a movie, a game, or software. SHA256 can convert anything of any length into a fixed size string of 256 bits, which is 32 bytes, which always look like this, a 64 character string. I'm sure you noticed I said that hash is almost unique. Why does that mean? What does that mean? We hope to make every block a unique fingerprint, so we can distinguish them. What if it's not unique? Just like two different people could have identical fingerprints, there is still a chance that two different blocks put into SHA256 could get the same hash. That's because the possible input value for SHA256 are infinite. SHA256 has 10 to power of 77 outputs, which is very big as well. But the possible outputs are finite, so theoretically, identical hashes exist. So two inputs for hash algorithm like SHA256 could hash to the same output, And this situation has a name, hash collision. We have 8 million people on Earth, but there are no identical fingerprints yet, not even one. That's because the chance of identical fingerprints is 1 in 64 trillion, which is 1.5 in 10 to the power of 14, an extremely small probability. But the chance of a hash collision happening in SHA256 is even much smaller than the chance of identical fingerprints. And this chance is 4.3 in 10 to power of 60, which is extremely low. And this exactly is the property of the algorithm we are seeking for a blockchain. And this property of SHA256 is called collision resistant. Collision resistant is saying that it's almost impossible to find two inputs that hash to the same output, which means if there are attackers who want to tamper with data or transactions in blockchain, unknowingly, it's almost impossible for attackers to find the same hash. So if they tamper the data, the hash will be changed, and any change will be found by people in the blockchain network. We mentioned this scenario in What is a Blockchain video 2. This is why blockchain is an immutable ledger. We will talk about this immutable ledger in detail in a separate video. So we have discussed the collision resistant part, the collision resistant property of SHA256 from the perspective of dealing with attacks. It's secure enough to face brute force attack. Let's go back to blockchain itself. As we all know, so far countless applications based on blockchain technology have been built successfully, like Bitcoin, Ethereum, and all kinds of decentralized applications. SHA256 is used to hash so many things for them. Has any hash collision happened in this process? Actually, hash collision is considered impossible to happen in this process. Why? Let's figure out why it's impossible using Bitcoin blockchain as an instance. So let's calculate the total amount of SHA256 hash used in Bitcoin blockchain, then you will see why. Total amount of hash used in Bitcoin equals total amount of blocks in Bitcoin times amount of hash in one block. So here are the latest Bitcoin blocks. They are near 800,000 blocks now. So there are 765,000 and 8,066 blocks in Bitcoin blockchain right now. And every 4 years, 210,000 blocks are produced, and all the bitcoins will be mined by the year of 200 and 2140. So there will be this amount of blocks when all bitcoins are mined. It's very clear. And now let's check the transactions. How many transactions in one block? So there are average 2,000 transactions in one block, and this is a Merkle tree in a blockchain block. So in a Merkle tree like this, in every block, to store all the transactions, and one transaction has one hash. Then how many nodes in this Merkle tree? One node has one hash. So there is 2000 transaction here, and the other nodes count together is this amount, which is 1999, and every block has its own hash. So the total amount of hash in one block is 4000, and total amount of block in Bitcoin times amount of hash in one block, we can get the total hash amount in Bitcoin block. It's 3 times 10 to the power of 10. But the combination amount in SHA256 is 10 to the power of 77. Compared to the combination amount in SHA256, the hash used in a blockchain is nothing. Its distribution is like throw a pound of rice to the ocean. That's why it's almost impossible a hash collision happens in blockchain. So when police are using fingerprint to solve a crime, what they will do is cross-check the fingerprint with all the fingerprints saved in their database. It usually takes some time, which could cause a delay to crack the case. Sometimes it's even worse. There is no record of fingerprints in their database, so they have to give up this clue. Because they cannot use a fingerprint to directly get a criminal information like height, weight, or appearance. This property is called one-way, and hashes produced by SHA256 are one-way. This feature might cause some problem in solving crime, but it's a perfect probability for cryptography that blockchain needs. It means that you cannot go backward. You cannot go from the hash to the document. You cannot do reverse engineer to a document based on the hash. The one-way property ensures the security of hash data. Now, let's have a look in action. What we can do is we can input some data and calculate its hash. Let's try 1 block, and we got a hash now. Let's save it. Okay, we got 1 block hash, and let's calculate something new. We got a new hash. Now let's calculate 1 block again. So we can see it's as long as we input the same data, it will always produce the same hash. And this is another property SHA256 has. It's called deterministic. It means if we take exactly the same document later on and we run SHA256 again, we will get exactly the same result as we saw before. Deterministic is also a common property of all hash algorithms. And we can also see, no matter this string, how long this string is, it's calculated quite fast, right? So what if we put a big enough file? So we have War and Peace chapter 1 here. War and Peace is one of the longest book in the world. So let's try calculate the whole chapter 1 here. Now we have pasted the whole War and Peace chapter 1 in this calculator, and we can see the calculation speed is still very fast. This is another property of SHA256. It's fast computation. This property is very important for proof of work in blockchain. This makes miner work very easy and very fast to verify. We'll dig into proof of work and mining in a separate video as well. Now, let's try change the War and Peace book. Change one letter, two letter, and we can see the process we change every time we change the data, just a small change to data, and the change of hash is very big. This is another property of SHA256 called avalanche effect. It means even if there is only a teeny change in the block, the hash of object changes completely and entirely. This is also an ultra important property of SHA256. Because of this property, attackers cannot correct the hash data and find the pattern of data by repeating the hash process. So these are the most five important properties of SHA256. So when we learn blockchain as one of the components of blockchain technology, we only focus on the role of SHA256 plays in blockchain, and we don't really need to know how it is implemented. If you want to know more about it, I have attached a source code of SHA256 in description box below. You can read it and understand more about how it works. So these are the 5 major properties of SHA256, and these are the reasons that SHA256 is used in blockchain, and at the same time, SHA256 is the most important infrastructure of blockchain. Blockchain cannot be built without a great hash algorithm like SHA256. Make sure you understand SHA256 if you want to understand blockchain technology. Thanks for watching. See you in the next video.